できて、短期的とね。うん。こっちも。じゃあでは始めますか。では始めます。まずは、これは、ほっといて、ブルージェイをやめて、
Hi. At this point, you've learned a ton about programming in general and about Java in particular. For a lot of the problems, you're going to be able to solve them on your own now. However, we have set things up with some simplifications to help you get through this course, such as using the BlueJ programming environment and providing the edu.duke library of classes. These have helped you focus on the key things you need to learn without getting bogged down in complexities of the Java language. However, it's time to move beyond these simplifications to let you know what's next. First, you're going to learn about main, the method which indicates the start of a Java program when you're not using the BlueJ IDE. BlueJ is great for novices, but as you become a more advanced programmer, you may want to consider more advanced editors, and we'll talk briefly about some of them. You'll also learn a little bit more about exceptions and why they're needed and how to handle them. We'll also talk about how you would read files without the edu.duke.star libraries with classes like file resource. Finally, we'll wrap up this course with a brief discussion of what you might do next. We hope you're really excited about programming in Java, programming in general, and computer science. And you're very eager to learn more.
Java の続きですね。The following indicate the method you would use to start Java with using BlueJ. そう、メインですよ、メイン。C から決まってる。
Hi. If you make a program that stands on its own, meaning you just want to run it, not inside of something like BlueJ, then how does Java know where the program should start? In BlueJ, you did not need to worry about such a thing because you just click the menus to tell BlueJ what objects to make and what methods to run. In any other setting, a program starts in a method named main. When you run the program, you specify which class the main method is inside of. The main method must have this particular signature: public static void main string array args, UG. You are already familiar with public, which means that code outside of this class may call the method. Main has to be public since it must be called by the code which starts up the program. The next word is static. It means that the method does not live inside each particular instance of the class, but rather there is just one of it for the class as a whole. You'll learn more about static shortly. For now, just know that main has to be static. Next, you see void, which is the return type of main. It does not return any value. Next, you see main, which is the method name. The parameter to main is a string array. You are already familiar with both strings and arrays, and this works just like any other method, which takes an array of strings. This parameter represents the command line arguments to the program. When you run the program, you can specify what strings get passed into this array. Now let's take a look at an example of a program written with main. Does this program look familiar? It is the Hello Around the World program from the start of Java programming solving problems with software. But it's been rewritten to use main, which you can see here. Notice how it has exactly the signature we described on the previous slide. The body of the main method then does whatever computation you want. In this case, it reads the file hello_unicode.txt and prints out each line in the file. If you wanted to make use of the command line arguments to main so that you could change what file the program reads without recompiling the code, you could do so. The code just uses args at 0 to get the first string out of the array of arguments passed in. Indexing into an array should be quite familiar by now. Of course, it is generally a good idea to check that the person who ran your program provided the right number of arguments. That way, if they did not, you can provide them a useful error message, rather than just having your program crash with an array index out of bounds exception. In this code, we made use of system.exit, which just tells Java to quit the program entirely. Here we do this since the program cannot do anything without knowing what input you want to work with. System.exit is quite useful when appropriate, but use it only when you want the program to quit completely. It takes an int indicating the success or failure of the program. By convention, pass in 0 for success and a non-zero value for failure. Great. Now you know how to write a main method so your program knows where to start if you run it outside of BlueJ. Thank you.
まあ、これは当然取るというか、どうやってクラスなし、宣言なしでやるか使って話になるよね。
You just learned about the main method, which is static. But what does that mean? It means that the method belongs to the class in general, but not any particular instance. To see what this means, let us first look at non-static fields, for which there is one copy per instance of the class. As an example, suppose you were writing some banking software. You decide to make a class for a bank account and declare fields for the account balance and account number. These are great fields for a bank account class because each instance, that is each different bank account, has its own account number and its own balance. If you made 3 instances of this class to store the data for 3 accounts at your bank, they might look like this. You can see here how each instance has its own account number and balance. These fields are not static. They exist in each instance. Now suppose that as you write this software, you want to keep track of the next account number to assign, so that when you create a new account, you know what number to give it. Creating an instance variable for this next account number, as shown here, would not work very well. Declaring this field makes each bank account have its own next account number, which is not really what you want. Let's see the problem this creates by looking at a constructor you might want to write, which uses this next account number to initialize the account number of the bank account being constructed, and then increments that next account number as you see here. When you create the first bank account object, all the fields will start with 0 values. Then you will execute the code in the constructor. The first line will initialize this object's account number from this object's next account number, setting it to 0. Then the next line will increment this object's next account number to 1. So far this behavior is fine, but you will see the problem when we create a second bank account object. This newly created object has its own copy of each field. Now when you execute the first line of the constructor, it uses the object's next account number to initialize this object's account number. Then you increment the account number inside the object to be 1. Oh no! You've ended up with 2 accounts with the same number. That will cause problems with your banking software. In fact, every account you create will be numbered 0. The problem here is the next account number is not a property of each different bank account, but rather something shared by all bank accounts. This is exactly what static is for. When something does not belong in each object of a particular type, but rather is shared by all objects of that type. Here you can see that we declared next account number to be static. Now that the next account number data is not stored in each bank account, but rather there is one copy of it shared by all of them. When you want to refer to a static field or method from outside of its class, you can do so by naming the class before the dot, since it does not belong inside of any particular object. For this field, you could write bank account dot next account number. So now you know a bit about static. For static fields, there is only one copy, not one copy for each object instance. These tend to be much less common than instance fields. Often you will want to describe objects in terms of properties that each instance of them have. However, there are times when static is appropriate, so it is good to know about. You can also declare static methods. With regular methods, you can think of them as being inside of each instance, but with static methods, as with static fields, you can think of them as being only one shared by all instances of the class. Static methods can only access static fields and other static methods of the class they belong to. However, they cannot directly access non-static fields or methods. If you wanted to access a non-static field or method from a static method, you would need to specify which object instances field or method you would want to operate on with that object dot the field or object dot the method.
とりあえず、ここら辺は、考えてて。これ関係ないよな。
You've used BlueJ throughout this course because it is a great tool for novices learning to program. It makes things easy for you, and there are not too many features to learn with it. However, as you advance in programming skill, you may want to explore other editors. There are many choices and trade-offs. Do you prefer simplicity or the power presented by advanced features? As you learn other programming tools, such as revision control systems like Git or debugging tools, how does your tool integrate with them? Another important consideration is whether you want to use a graphical user interface, or GUI, which may feel more familiar and comfortable to you, or something where you only use the keyboard. Using only the keys may seem intimidating, but it allows you to work from muscle memory. When you can edit from muscle memory, your editing doesn't interrupt your thoughts about your algorithm design and implementation, which can make it much more efficient. As you think about these factors, there is a wide spectrum of editors, ranging from those which are more friendly to novices to those which are more friendly to experts. Novice-friendly editors, such as BlueJ, are GUI-based and favor simplicity over power. As you work your way down the spectrum, you find editors providing more advanced features. One popular editor is Eclipse. There are also two very common editors aimed solely at experts, Emacs and Vim. Programmers who use these editors primarily use the keyboard and enjoy the advanced features they provide. However, their power comes with a cost of a learning curve. Emacs is what Drew teaches his students to use in class. So if expert-friendly tools, whether editors or other tools, are harder to learn, why would you want to learn them? Learning them is an investment if you plan to use them over the long term. If you look at what you can do with a tool versus the effort you have spent learning it. For a novice-friendly tool, you can just pick it up and use it, and do a decent amount with it. As you work with the tool, you can do more, but you quickly plateau in what you can do. If you look at an expert-friendly tool, you find that when you start out, it is more difficult to use. You may not be able to do much with it until you invest some effort into learning it. However, as you invest effort into mastering your tool, you surpass what you could do with a novice tool, and then benefit from the power of the advanced features. As an analogy, think about recording video. For most people, a novice-friendly tool is great. If I'm going to record a video, I take out my cell phone and press the record button. It's super easy, and I didn't have to do anything to learn how. But professional videographers use much more sophisticated tools. A high-end professional video camera has a bunch of complicated features, and I wouldn't know how to use one without investing some time in learning it. If I wanted to use any of the advanced features, it would take even more effort. I can stick to my cell phone since I don't need those features and I'm not a professional in that field. However, for professionals, learning to use the advanced tools is a worthwhile investment. The same principle is true of editors. If you plan to be a casual programmer and just write small programs, a simple editor may be a good choice. However, if you plan to become a serious professional programmer, you will want to invest the effort in learning an editor whose advanced features will make your job easier in the long run.
Consider as novice editors on database. Two best answers. MXB も選べと。どっちかっていうのはまああれですよね。GUI か。Following item would be considered as novice editors and are GUI based. Problem implicit overpower. 第一項。ブルージェイとエクリプス入れるんじゃない。キャストメイトっていうのを入れるってことか。はい。
Hi, I'm going to walk through using Eclipse, an integrated development environment, or IDE, that's the IDE of choice for many Java developers. I've used it to develop most of the material for this course when I'm not using BlueJ, and the UCSD specialization that comes after our specialization also asks learners to use Eclipse. As you know, there's some other IDEs as well, but because I'm most familiar with Eclipse, I'm going to walk through just a few of the features that it has to show you what it's about. I'm using the class Markov runner that we've used before, and I've created Markov 0, Markov 1, and Markov 2. We've gone through those in previous lessons. I'm going to use Eclipse to make Markov 3, a class that we haven't done yet. We've gone in previous lessons right from Markov 2 to the general Markov model. So in Eclipse, I'm coming in just as you do in BlueJ and saying I need a new Java class. I get a little menu, and I'm going to call this Markov 3. The interesting thing about Eclipse is I can say, here's an interface that I'd like to add. And I'd like to add the Markov model interface. I'm going to say OK. When I'm finished, now I have my Markov 3 class. And you can see that Eclipse has filled in the stubs for all the methods I need to implement that are part of the iMarkov model interface. As a reminder, here's the iMarkov model interface. It has two methods that I must add, setTraining and getRandomText. We've seen that before. And stub implementations for those were provided in Markov 3 by Eclipse. It even has a return value. That's not the right return value. And it does the setTraining method here. So the nice part about Eclipse for what we're seeing here is that for interfaces, Eclipse will fill in the stubs, and then I can copy the code from Markov 2 into here and make sure that it runs. I'm not going to do that now. I just wanted you to see that with interfaces, that's a nice feature to have. If I started to copy the code in, and I'll just do it a little bit so that you can see what happens. Here's the getRandomText function. This, I'll just copy the first few lines into my Markov 3 class. If I had forgotten, for example, in this case, this 2 is going to be replaced by a 3. We've walked through that in a previous lesson. sb.append. When I type sb dot, I see a menu pop up of the choices for this method, including append. Now, BlueJ has the same functionality if you do a control space or a right-click space. In this case, I'm just going to make sure that I call append properly and put in current. BlueJ also has that functionality. Here, if I forget the return statement, I get some red X's. Eclipse is going to complain. In this case, it's told me that it doesn't know where my random is, and it doesn't know what my text are with these little red X's. I do a pop-up, and it can say, create a local variable or create a field. So I'll create a field, my text. And Eclipse came and set this variable, my text, knowing how it was used here. I can do the same thing here for my random. I will add the field my random. It added that up here. It thinks it's an object. It couldn't know that it was random. I'm going to change the type to random. I've got another red X. Import the class random from java.util. Eclipse knows where this class lives, and so it filled in all this material for me. I'm almost done, but I finally have a red X here because, as it says, if you could look really closely, add a return statement or change the return type to void. I'm missing the return statement, so Eclipse makes a guess and says maybe I should return current. That's not correct, but it's enough to make my program compile, and as you've discovered, once the program is compiled, I can run it, and that means I can test it and go back and make corrections. So that takes care of a few of the features that Eclipse allows me to have and make my programming a little more productive by helping me correct my own errors. One more interesting feature that Eclipse can do. I can say I don't like the variable name my text. I'd like to right-click, refactor. I'd like to rename this variable. I think my text is not quite right. I'd like to call it my training text. So when I make that change there, Eclipse has gone through and found all the occurrences of my text. You can see them highlighted, and they're changed there. Refactoring in Eclipse has many powerful functions that we're not getting into here, but if you continue and do more advanced object-oriented and Java programming, you'll see them. Happy programming!
というわけでまとめ。
Great. So now you know the basics of Java outside of BlueJ. You learned that Java programs start at main, which is always declared as public static void main string array args. You also learned what the word static means, which appears in that method declaration, that a method or function belongs to the class as a whole, and not to each particular instance. Finally, you learned a little bit about editors beyond BlueJ, and we discussed that there are a wide range from novice-friendly to expert-friendly. What editor is right for you depends on what your future programming plans are and how much benefit you could get from investing the time to learn an expert-friendly tool versus how much you would prefer the ease of a novice-friendly tool. Thanks.
というわけでメインストリーム。続けて。
カフカ、フランズさん、こんにちは。Java か、全然使ったことないな。
ですね。今は JavaScript とか、そっちのフロントエンドが普通ですからね。ここはまあ基本的なプログラミングの練習を Java でやるっていうところです。まあ Java の IO ライブラリが使えって話ですよね。
Using Java's IO libraries requires some new concepts that we've not covered. Putting these topics off until now, when you have the Java skills to understand them, is why we provided you the edu.duke libraries at the start. The first of these is exceptions. You have seen a little bit of these. Maybe your program has crashed with one at some point, but we have not gone into detail on them. The other is to dive into Java's IO libraries. There are actually two different ways to do it, and we're going to cover the in-IO library. As a side note, if you want to know how to pop up that file selection dialog you get when you do new file resource with no arguments, that's way more complicated, and we're not going into it here. Of course, you can take a look at the code if you want, since it's open source.
Understanding exceptions. ああ、例外の発電の話ね。
Hi. You've probably seen exceptions and know that they mean your program crashes because something went wrong. But what exactly are exceptions? And why does your program crash in this particular way? How could you use them in your own programs? An exception means that the program could not do something that it tried to do. Sometimes this indicates a mistake in the code, such as when you access an invalid index in a string or an array. However, sometimes an exception indicates a circumstance beyond the programmer's control. The user asked your program to open a file that does not exist, or their internet connection went down while your program was trying to download information. Real programs have to deal with such problematic situations, and exceptions are actually one of the nicer ways to handle these types of problems. This exception message, which is likely similar to something you have seen before, is called a stack trace. When your program has an unhandled exception, one that indicates something went wrong and your program did not say how to deal with it, your program crashes and prints a stack trace. If you look at this in detail, it starts by telling you there was an exception. Something went wrong. Then it says in thread main. We're not going to talk about threads, which are a fairly advanced concept. And unless you start using them, you can ignore these few words of the message. Next, the message tells you what kind of exception happened. That is, what sort of problem the program had. In this example, I made a mistake in my program and accessed a string at an invalid index. So I got a string index out of bounds exception. Many exception types are nicely descriptive of the problem, but you can always check the documentation for more information. Next, the message provides some more information about the problem. Here, it tells me what the invalid index was. I tried to access element 82, which was not legal for that
この
string.
場合はバッファーが
The information
82 に
here
も
will
なかったっ
depend
ていう
on
こ
the
とね。
type of exception you have. Lastly, the message has the stack trace, that is, the list of methods which had been called but not yet returned when the problem occurred. Here, the problem happened inside of strings.caret method, specifically on line 646 of string.java in the Java library. The next line shows what called strings.caret method, which was dostuff in test.java on line 5. This is the first method that we see that is in my code rather than a library, which is generally where you will want to start looking for the problem. Last, it shows where main called dostuff on line 8 of test.java. We just said that your program crashes and prints a stack trace if it does not handle the exception. Your program can, however, handle an exception, specifying what to do to deal with the problem. Handling exceptions involves 3 new concepts: try, catch, and finally, which you will learn more about shortly. After you learn about try, catch, and finally, you will learn about exception propagation, where a method that does not know how to deal with an exception will propagate the exception to its caller. The caller can then either handle the exception or propagate it to its caller, and so on. You do not have to do anything explicit to propagate the exception, which is one of the key benefits of exception-based error handling. But you do sometimes need to declare that the method might throw an exception. Finally, you will learn about throwing your own exceptions when your code discovers that a problematic situation has happened. Thank you.
プログラムが unable to express there is no exception が発生する。で、その時にはどうするか。
Suppose you have code which might experience a problem. For example, if you use Java's built-in URL class to work with URLs, its constructor can throw a malformed URL exception if you pass in a string which is not a valid URL. Maybe you read this string from the user and do not want your program to crash if the user made a mistake. How would you deal with this exception? The first thing you do is put the code that might throw an exception into a try block. A try block starts with the keyword try, and then wraps the code that might have problems
とに
inside
か
of
く
curly
何か
braces.
処理をして、
Immediately
が発
after
生
the
する
try
ところ。
block, you write a catch block, which states what type of exception you want to handle. In this case, malformed URL exception. And then has the code you want to do whenever this problem occurs. You name the exception, much like declaring a parameter, which gives you access to the exception object. You can call methods on it, and if you need to get more information out of it, the code in the catch block can do whatever you want. For example,
ジャッ
telling the
ジ
user
は
that the
例が
URL
発生
was
した
not
時の処理
valid
を。
and asking them to enter a new one. When the string is a valid URL, no exception will be thrown. In such a case, Java will execute the code inside the try block as normal. When it reaches the end of the try block, it will skip over the catch block and continue to execute the code after it. However, if the string is not a valid URL, then when somewhere inside of this constructor a malformed URL exception will be thrown, Java will then go inside the catch block and begin executing whatever code you wrote there to handle the error. After finishing the catch block, Java will continue to execute the code immediately after it.
URL の方で
You can also use a finally block, which is always executed whether or not an exception was thrown. Finally blocks are often used to clean up resources which were allocated and need to be freed regardless of what happened. Java 7 also introduces a try with resource construct to simplify releasing certain types of resources, though we aren't going into that here. Thanks.
Which type of block would you use when you want to state the type of exception you want to handle? キャッチ。次は、例外の定義。
So what if you were writing code where an exception might happen, but you don't know how to deal with the exception right there? Maybe because you are writing a method which may be used in a lot of different ways, and what to do depends on how it is being used. Or maybe you just need information that isn't in this method. In either case, you really need the method that called this method to handle the problem. Or maybe its caller, and so on. In fact, if you think about the fact that the constructor for the URL threw an exception, it is exactly because it detected a problem, but it did not know how to deal with it. This is the whole point of exceptions. Fortunately, when you do not handle an exception, it will propagate to the caller automatically. However, for certain kinds of exceptions, called checked exceptions, you need to specify that the method might throw them. You do this by writing throws and the name of the exception types it might throw after the parameter list, but before the curly braces, as you see here. We aren't going to delve into the details of which exceptions are checked, but you can read more about them in the Java documentation if you want.
いわゆる例外を投げる方法。
You can throw exceptions in your own code whenever it encounters a problem it cannot handle. You have seen this principle already when writing your Markov code. This piece of code comes from that lesson and gets a particular word from the wordgram class. As you can see here, it throws an exception when the requested index is invalid. The code has encountered a problem that it cannot deal with. The program will crash unless some caller of this method catches the exception. The syntax for throwing an exception is to write the keyword throw, followed by an expression which evaluates the exception you want to throw. As is the case here, this expression will typically make a new object of whatever exception type is desired, passing in any useful information to the constructor. So what exactly can you throw? Technically speaking, any class which extends Java's built-in throwable class. However, more common is to throw an object of a class which extends exception, which itself extends throwable. Java has 57 built-in exception types. Well, okay, maybe not 57 billion, but it sure has a lot. Some of these may be familiar, such as array index out of bounds or null pointer exception. IO exception is another common one, which indicates a problem reading or writing data and is why exceptions are important to understanding how to read files on your own. Most of the time, the built-in exceptions will provide you with whatever you need, and you can find out more about them in the Java API documentation. If you write a program where you need exceptions beyond the built-in ones, you can always write your own. You would do this by writing your own class and making it extend the appropriate existing exception type. We aren't going to delve into the topic of creating custom exceptions, but we wanted to mention it as part of our discussion of exceptions in case you ever find yourself needing it in your future programming endeavors.
次は Java NIO クラスで
In this lesson, we're going to provide reasons for why we decided to hide some information about how files and URLs work with Java, and how you can write programs using standard Java libraries. Having to understand the details about how files and URLs are used in programming can easily get in the way of solving higher-level problems. That's why we provided the edu.duke library and the class file resource to help you more quickly solve real problems by programming. All languages and all libraries insulate programmers from complex details that can get in the way of solving problems. The libraries we provide are a great insulation and protection for those first learning Java, but even the regular Java classes provide insulation and protection. We've worked to empower you to solve problems, to think creatively about writing programs that will help you learn about programming and problem solving together. Now, we'll show you how to write the Hello World program without using the file resource or URL resource classes. See how this is done could help you implement your own classes to insulate common issues you have while programming. What for us was 2 classes in the edu.duke package plus a third exception class that some of you may have encountered will be at least 6 classes in 3 different packages that are harder to use than the classes we designed. Using the Java libraries will require understanding exceptions and several programming idioms that are more complex than the simple for-each loops we started with. Let's look at one of the first Java programs we used to print Hello World in several languages. This code uses the .edu.fileResource class and the method runHello, as you can see here. This method prints Hello World in different spoken and written languages by reading the text from many languages and printing the words read. The code first creates a file resource object to reference and read the file containing the words we want to print. Then the method loops over each line in the file using a for-each loop as shown here, reading a string and printing the string in the body of the loop. Let's look at the same code that uses Java, not our libraries, but rather a way to do this with just the standard Java libraries. This code uses 7 classes in 3 packages. Both programs use the system class. There are many ways to do this, but the one that we're showing will highlight some of the flexibility these extra classes provide to reduce duplicated code. The first step is to create a path object. In the code, we've named this object P. It represents a path to a file in the file system. Here we've used the paths.get, note the extra S, to get the path. The idea of a path is the same with a file or a URL, something that goes from folder to the file in the actual file system. One standard way to read a file in Java is using a buffered reader from the java.io package. The paths and path classes are in a different package, as we'll soon see. To create a buffered reader, we first ask the files object, again, note the S in files, to create one for us to use in our program. We'll see other ways to create buffer readers when we use a URL instead of a path to a file. We use a loop and the reader.readLine method to read each line of the opened file until a null reference is returned by readline. That means the file has been completely read and the loop exits. Both this code and the code with our file resource object use loops, but the loops are different. The 2 main packages we use to read files in Java are java.io and java.nio. The N in NIO is for new, though the package is actually old, but it is newer than the java.io package. The I stands for input, reading, and the O stands for output, writing. In other words, these are the input-output packages. The classes paths, files, and path are in java.nio. These classes, files, and paths use static methods, which you have recently learned about. You know that these methods do not belong to a particular instance of a class, but rather the class as a whole, so you do not need to create new objects to use them. Many of the methods for doing reading and writing, as well as some constructors, can throw exceptions. Now that you've learned about the basics of exceptions, you know that you should handle these with try-catch blocks, and that if you do not handle them, you must add a throws to the appropriate exception type to your method declaration. The java.io package provides other classes for reading and writing. The buffered reader class is often used when reading sources, buffering what is read for good performance. The java.io.io exception class is thrown by many input and output methods. Using these classes requires reading the documentation and looking at examples because there are many ways of reading files, raw bytes or objects or parsing information. We created the file resource class to make these things simpler. Let's look at one more example, how to read URLs without using a URL resource, but using the java.net package. Reading URLs with this package is similar to how reading works with our edu.duke.url resource class. First, you create a URL object by providing a string that represents the website. You'll then use this URL object to create a buffered reader from the java.io class. But that takes several steps. The first step is to open a connection to the associated URL and get a stream representing its data. Then use this stream to create an input stream reader. Then use the input stream reader to create a buffered reader. That's 3 steps to replace the 1 step we had in creating a URL resource object. The purpose of these extra steps is to provide different ways to create an object that implements the reader interface so that you can read the data from a file or a URL using the same code. So, you read using the same buffered reader loop that we used in the last example. This kind of reuse is harder to do with our simplified resource classes, and one of the reasons it is useful to take the time to learn more about these complex classes.
Java in a package which the following classes use results. Files pass the height. Hello around the world with Eclipse.
Hi, I'm going to go through the process of writing Hello Around the World, the first Java program we did, in which we used the edu.do classes to read a text file or a URL and say Hello World in many languages. Something like Bonjour Monde, which is a language I speak a little tiny bit of, and then other languages as well. You've already seen a walkthrough in a previous lesson of the code here. I'm going to show you what happens in Eclipse to show a little more deeply how this code works, and also, again, to show you the power of Eclipse. I've taken the code that was part of that previous lesson. This is the function that opens a file. In this case, the file is hellounicode.txt, makes a buffered reader from that file, and then loops through the buffered reader input to print out hello world. Eclipse is telling me with these red X's that something's missing. It says import path, because Eclipse doesn't know that path is a class, but Eclipse does know that it's in that package, so it's imported java.nio.file.path. I still have a red X because it doesn't know about paths, so I'm going to say please import that as well. Now I've imported 2 different classes. Buffered reader is something that Eclipse doesn't know about. Let's import buffered reader. And it doesn't know about files, so I'm going to input files and buffered reader. If I come up here, I'll say I've got buffered reader, files, path, and paths. One more right click here. Unhandled exception. When you open a file or when you read a file, an exception is going to be thrown. You've seen lessons about this. I need to either rethrow the exception or put a try-catch block around this. Eclipse gives me the choice. I can add a throws declaration or surround with a try-catch. For right now, I'm going to add a throws declaration. That means Eclipse came in and added this throws IO exception, and now we can see that my function here to read and print is complete. My function down here that reads from a URL is not quite ready to go, so I'm just going to comment that out because I'm not interested in it. I'm toggling the comment, and Eclipse comments out every single line. Now, I can come down here and I can see that I want to call this method read and print in my public static void main function, so I will do that. I'm going to run this program by clicking the Run button, and we can see down here in my console window, which I will make a little bit bigger, that it said hello world in all the different languages. Hello, ciao, merhaba. That's about the most I'm going to do. That was reading the file that was local on my computer. Now I'd like to go one more real quickly and read the URL. So I'm going to uncomment that. I've got a couple of red X's because Eclipse doesn't know where the URL is. So I'm going to import the URL class from java.net. I've just added that. Then I'm coming down here and it doesn't know about input stream reader, which is in java.io. So I'm going to input that. I've got a malformed URL exception. I must add a throws declaration or catch it. So you can see I've added malformed URL exception. And then here I've got an IO exception. And you can see that it replaced malformed URL exception with the more general IO exception. There's an inheritance hierarchy for exceptions, and IO exceptions kind of the parent class of all the possible IO exceptions. So now this method is done. Read and print URL. I'm going to call that by editing my main. Now, when I run my program, it will go to our DukeLearnToProgram.com website, read the file that we've stored there, and run. It might take a little bit longer, but as you can see, I've still got hello around the world in all these different languages. As we say where I come from, hola, enjoy your programming.
Okay, so now you've learned about exceptions. You can throw them when something goes wrong with your program. You can use try and catch to handle exceptions when you deal with code that might have something go wrong. Or if your code doesn't know how to handle the situation, you can declare that your method throws and whatever exception type might happen. You've also learned about accessing data on your own. You can use the java.nio package or the java.io package or a mix of the two. These have a bunch of classes, so you'd often want to consult the documentation as you become familiar with them. Of course, things can often go wrong when you try to access data. Files can be missing, the internet can be down, so these may throw exceptions, which fortunately you now know about.
We have listed the fourth course of this by development. You know a lot about programming on Java. The interview admits. This presentation capstones. We hope you will be US in capstones. UC is this. 例えば終了としてんば。次の項目に進むと。テスト。Java Tools and Libraries for Everyone. Here's the name of the method that starts the program. Main. What are your types of business? What I have to count the feeder stick. There's only one copy, but that's feeders in the class. Not one per instance. In Java, how is it together slow use? In Java, how is it to on the exception has already occurred? 違う、to make an exception だよ。こっちでエクセプションを作る。これで next out with get S ように作った output can throw an exception on this Java next gets class. Which following structure is the best way to create a script with an exception? 違う。これからスケットコードするまでからのこと。これスケットするコードだという。違う。これスケットコードにしてコードハンドルする。これだね。In Java, how is keyword finally used? Replace the code to immediate for 違う。 in exception handling specialこととbe expressed. If you wanted to that wanting test of a file without using an ADP, you might call files new file new. What do you pass into files new file new? Pass. If you need to read data from a website without using a ADP package, you would probably use ソケット、ジャパネットか。Use the buffer data can be used from a file on the local computer, as well as from a website. You would also use These capabilities are great examples of the benefits of weak programming principles. Best option. オープンクローズプリンシプルかな。だけじゃないか。A particular class can work with any class that confirms that specific interface does not use 違う。Including buffer records into some interface. そうだな。送信。88% か。最後のバファディーラーが失敗だった。で、次の項目に進む。プログラミング Java と。これで、課題提出をするフィードバックを見問題を。4週目。レビューも完了したから、すべての採点結果が終わりました。あなたは最新的な見切りありません。というわけで、成績メッセージ。終了証ができましたと。ビデオを見て、そういうのはできますよというところだけだったな。あとはそうすると、進行中で、ランドファンダメンタル。タイプスキルを作ってやりましょう。約2時間のプロジェクト、10分のリーディング1個が残っています。こっちは後にして、じゃあ、こっちかな。1時間のプロジェクトの中に、プロジェクトイントロダクション。
Hi, my name is Ravi Perlena, and today you're going to learn how to program. No previous experience necessary. Now, being a programmer is about learning to speak to a computer, but it's also about learning to see possibilities. In this guided project, you'll learn the basics of programming, but you'll also learn one of the most important skills a programmer needs to have: how to turn small ideas into ideas that scale. Because when you write even a few lines of code, you're creating a seed. Your computer then transforms your code into creations larger than anything you might have ever thought you could make. In this guided project, you're going to learn to think like a programmer by solving a crime. The crime is a fictional one, but the skills you'll learn are fundamental to being a programmer. They'll enable you to spot connections between the power of programming and real-world opportunities. As an example, a few years ago, my sister came to me with a problem she was having, helping her children stay focused. I programmed an app to help, then watched as it was shared with more and more of our friends. Today, that app is being downloaded by millions of users and resulted in my being offered hundreds of thousands of dollars worth of contracts with global corporations. Families around the world have sent me emails telling me how the app was able to help them, even more than it did with my sister. Or, as another example, one day, I was trying to learn a foreign language, and I programmed a simple system to help myself. Later, I found my program was being featured on the front page of the BBC World Service and syndicated on numerous news sites around the planet. These are just two examples that show how a programmer can take something that starts off small and turn it into something that reaches people in every part of the world. If that sounds exciting to you, you're in the right place to get started. Now, whether your end goal is to become a professional programmer, to start your own company, to learn to program with your kids, or just to be part of the conversations about the scale of possibilities that come when you can think like a programmer, this project will give you a firm start. And after our time here, you can continue to build your skills in subsequent guided projects. Now, the activities in this project were carefully chosen after reviewing 40 years of extensive research into the best ways to introduce computer programming skills. In fact, computer science is one of the highest dropout rates of any subject. This is because most beginner programmers get stuck when they try to learn both how to think like a programmer and code all at once. We'll start by coding with puzzle blocks in a series of exercises designed to getting you thinking like a programmer. Next, you'll learn how to take these puzzle blocks and transform them into actual code. This approach has been scientifically proven to save beginners endless frustration and confusion. We'll then take advantage of some of the new possibilities for learning granted to us by the modern cloud-based environment offered in this platform. Finally, you'll take the skills you learn and apply them in a detective mystery challenge, where you'll sort through thousands of lines of data to find a thief. Click the button to continue on to the next section, and we'll launch into our cloud-based environment and get started.
わかった。わかった。というわけで、お母さんが帰ってきたので、今回はここまでにします。あとは、ご飯食べてからかな。じゃあ今日はありがとうございました。ではでは。
ディスコンネクト。